This is Shakil Ahmed. In this tutorial, we will discuss about cross-validation. There are different types of cross-validation, but in this video, we'll focus on validation set approach. That is, we are just dividing the data in two parts. One, the training part, and the other is the test part. And the other cross-validation approaches are the leave one out cross-validation, that is loop cross-validation, and k-fold cross-validation. I repeat it, k-fold cross-validation. So in couple of next videos, we will discuss these topics as well. So cross-validation is needed when we want to uh, test or check the performance of our model. Basically, we are fitting certain models in statistical learning or machine learning or regression analysis. We want to check whether the fitted model is how the fitted model is performing for an unseen data, where we have uh, the model is trained for some part of data and we check how the model is performing for the other part of the data. So for this purpose, we need to apply cross validation. So we start with validation set approach. This is called validation set approach. We are just dividing the data in two parts. So I have a data on heart disease with different characteristics of patients. So just importing data in CSV. And when you import in this with this command CSV, the data uh, come with the double option, that is just created like a data frame, but the form is called the table form. So we need to change the table in data frame as dot data dot frame and then data set. So you can see now it's the data frame format. We have age, sex, blood CP, and stress, blood pressure and cholesterol level and FPS. So these are patients' demographic and clinical characteristic, and the target is whether the patient has heart disease or not. But in this example, I am just running a simple linear regression model. So I will take the old peak of the glucose level. I think it is for glucose level. So I am just keeping this variable as the dependent variable. The response variable are the predicted and fitting the model on age, sex, and other type of characteristics. So we need to for data manipulation, basically for visualization and data manipulation, we need the uh, tidyverse package I have already installed, and the ggplot package you can also install, and the caret package is required for dividing the data into splitting the data into test and training part and performing the cross validation tasks. So what is validation set approach? A random sampling of the data set. Basically, it does the random sampling of the data. A model is trained on the training data set. The resultant model is applied to the testing set. Basically, we just divide the data in two parts, just based on random sampling, randomly separate the data in two parts. One the training part and the other as the testing part, and calculate the prediction error by using model performance matrix setting. And we need to set seed. Basically, we are using randomization. We are selecting random values. So we need to set seed as This is required for randomization. And just checking the heart disease again, it's again coming as the in terms of table form. So it's okay if you want to change, then you can just name it as data frame or something else. But you need to write as dot data dot frame to convert the data from table to data frame. So we just need to create a random sample that divides the data uh, based on the predictor variable. We are just basically doing random sampling of the predictor variable in proportion of 80%. That is, list is equal to false. It means we are doing without replacement. So we are just dividing the data into parts. And what will be your training data set? That is herd and random sample. Means you have basically selected a random sample from the data, and on the basis of this random sample you will just divide the data uh, in training part and test part. Basically you can do just using the sampling command as well, but this is a good command. You are just creating a selecting a random sample and select the cases with a random sample, and the selected cases without the random sample means that those observations that are not selected in sample. It is selecting the observations, all the cases in the herd data that is available in this random sample, and this is selecting the cases that are not in the random sample. So we have just the training part and the test part, and then we build a model for the training part. We are just using the dependent variable, and the data is training data set. It will include, and first I have selected first 10 variables. I am including first 10 variables in building the model. You can just check what are the first 10 variables. Although the first 10 variable also include the old peak, so this is this will automatically take as the random variable, and the remaining the dependent variable and the remaining variables will be taken as the regress. So let's build the model and check the summary of the model, which will include the model estimated value parameters and the standard errors and the t values and the p values. We have just created a linear regression model using lm command, and we can see the summary, and then predict the values for non-sampled part, that is the testing part, that those values that were not selected in the training part. So we are just checking how the prediction is working in and the prediction the unobserved part of the data. So you can just see the predictions. These are the predicted old peak values for the testing part. Now we will uh, construct different types of performance metrics like R square, that includes that use the predicted values and testing data set, and the observed values. These are the observed values and the predicted values. There are three performance metrics we are using: R2, that is R square, and root mean square error, and mean square absolute error. So R square means the simple value of R square, that is sum of square 1 minus sum of square residual divided by sum of square total. and the residual means the predicted values minus the observed values, and the root means you can use the residual variance and the square root of the residual variance, and mean absolute error use the residual absolute value of residual and take the average of on that residual. So we are using these three metrics, and we can just run. So this is your class validation result. The R square value is 0.15 and the RMSE value is 1.096 and the MAE value is 0.85. So the model is not performing well as the R square value is very small, and you can check you can compare different models and models with different independent variables based on these metrics, performance metrics. So this is just a simple method of cross validation. You are checking how your model is performing for unobserved data that is not included. Those data were not included while constructing or training your model. Thank you.